Now, this is turned on. Okay, good. What we're starting today is something called congruency shortcuts. Because up until this point, and I've kind of said this before, if I wanted to show that this triangle ABC is congruent to this triangle here, we'll call it EFG. Well, I would need to know that the angles matched up. All the angles are congruent to at least one angle, that those matched up in some way. I'd also need to know the sides matched up, that I had congruent parts for both triangles. Because I needed to know everything. I needed to know all the angle measures of both. I needed to know all the side lengths for me to be able to say that these two are congruent. But we don't need all this. And that's what's going to make these shortcuts nice. Congruency shortcuts are going to help us be able to show that two triangles are congruent without knowing all three sets of sides and all three angles. Now, there's several of them. We have side, side, side. We have side, angle, side. We have angle, angle, side, or sometimes it's called side, angle, angle. It's just flipped. We also have angle, side, angle. And lastly, we have angle, angle, angle. Now, these here are all the different shortcuts that could possibly work. Now, I'm going to say that statement again. Could possibly work. Not all of these work. Because all of these here, side, 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 angle, angle, side, or side, angle, angle, because we can flip it, angle, side, angle, or angle, 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 are all the different sets of three pieces of information that we need. Because with these shortcuts, you're only going to need three sets of either sides or angles. And these are all the possible setups that we could have. Not all of these are going to work. And so today, and then what's going to end up being Monday, Tuesday, we're going to look at all of these. But today, we're not looking at all of them. We're just looking at side, angle, side congruency theorem. And this one here does work. This one here does work. At the end of the lesson, I will kind of show you kind of some examples of this and seeing how this works. But it works out that if I have two sides in the included angle of a triangle is congruent to two sides in an included angle of another triangle, those two triangles are congruent. So if I'm given two congruent sides and two congruent sides and the angle between them is congruent, it means the two triangles will be congruent. And this is kind of one of the written proofs of this here. Well, we always start with the given information. So they told us these two things here. Now, we already have a side because I need a side, angle, side. That's our first proof, side, angle, side. Now, the next thing we're going to say is BCA, this angle up here, is going to be congruent to DAC, this angle here. Alternate interior angles. That's why we have parallel lines. Those would work. Now, what am I missing? Because we're trying to show side, angle, side. I have a side, yes? I have a set of angles. I'm missing what? A set of sides, yes? And doing this proof, I'm going to put this kind of tidbit in. You're not going to have to do a proof showing that side, angle, side works. We're doing this here to kind of show that it does. And I will do another example later on with an overhead projector showing you different ways that this does work. That we can create another triangle using side, angle, side that will be congruent every single time. Now looking at this here, what are we missing? We're missing a set of sides, because we have a side angle, we need another side, yes? Hey, AC is congruent to itself, isn't it? AC or CA, those lines are congruent because, well, it's really the same line. So side angle side are congruent. So we can say that these two triangles are congruent by side angle side. Because if I have two sets of congruent sides with a set of congruent angles between them, the two triangles are congruent. So out of all the ones that we possibly have, and side angle side is one of the ones that will work. It'll work every single time. Any questions on this here? Okay, that's fine. So this is nice. This is a nice thing to have, this side angle side. Because before today, we would need three sets of angles knowing that they're congruent and three sets of sides knowing that they're congruent or paired up. Now I only need two sides and an angle in the middle to be able to say two triangles are congruent. It's a nice thing. We ready? Okay. We're going to talk about indicated angles. Name the indicated angle between the two given sides. So AB and BD. What is the indicated angle between these two sides? It'd be what? It would not be angle A. Well, I can't, well, B is on the right track. But how many angles are at point B?
Two, so angle ABD.
ABD. Because it's where those two lines meet up, yes? Did the question kind of give it to us? The answer? A, B, D. Because it's the angle between those two lines. So angle ABD is the indicated angle. The angle between the two lines. Questions on this here? Okay, I got another one. DC and CB. Bless you. Angle DCB would be the indicated angle. It'd be the angle between these two sides.
Could it be in any order, or does it have to be that order?
We could also say what? What's another way we could say it? DCB or DCD. We can flip it. Yes, sir.
Is that line heat like in the middle? Or is that?
Yes, sorry, I drew the wrong one. It would be this one here. Thank you. Thank you. And really, I'm realizing this should be included, the included angle, because it's the one in the middle. Because our theorem talks about what? If two sides in the included angle of one triangle are congruent to two sides in the included angle of the second triangle, then the two triangles are congruent. That's what it's talking about, the included, not the indicated. It might be interchangeable, but this here. Now, because there's only one angle there, kind of jumping back to topic, it could be angle C. Because how many angles are at that angle? One, since there's only one there, we can use the vertex. The other one had two, so we can't use it. Questions on this here? We good with this here? So DC and AD, what would this angle be? ADC or angle CDA, which is not to be confused with the CDC. Unfortunately, no, because how many angles are there? Because we have ADB, BDC, and then we have the whole angle. So we have several angles there. So we can't necessarily use that, but here A and C would work because they're by themselves. Because this angle and this angle would work with one letter because they're by themselves. Now, if we're working with separate triangles, like I drew at the start, those two separate triangles, we could use just vertex. But because those two angles, there's more than one right there, we can't use the single letter. Questions on this here? Last one, let's do this one here. AB and AD. What would the angle be? BAB or
This one could be named angle A.
yes. Because angle A is by itself. So we can name it angle A. Questions on this here? State if the two triangles are congruent. If they are, state how you know. Is there enough information here to say that the two triangles are congruent? Okay. So we can say yes. How do we know? Well, side angle side, that's the only way we have, right? Because if I look at this here, I have a set of sides here that are congruent. I have a set of right angles. Where's my other side? Because both of those triangles share that side length. So is it congruent for both triangles? Yes, I mean, anything is congruent to itself. So this here is yes, I have side, angle, side, side, angle, side. Questions on this here? You good with this here? Let's look at the next one. Are these two triangles congruent? Well, let's see what we have. I have a set of sides that are congruent, yes? I have a set of angles right here. And well, this side's congruent to itself, yes? So are these two congruent? Let's see what we have. I'm going to use purple. So I have side, angle, side, yes? Here I have what? Side, side, angle. Are those the same? No. When we have these here, these statements, they have to follow the same order. I have to have side, angle, side. Where the sides match up, the angles match up. What is congruent, the order matters. Because here I started out with my set of sides that were congruent. I call this 1 and this one 2. So 1, 2. Now 1 goes side and then has its angle, then A. Now the other one starts with a side, then hits A, and then an angle. When we're doing these here for side, angle, side, we're following along the triangle. Now I picked that side to start with because they were congruent. Yes? So I started with it, then I traced around the triangle of what I had. Now, if you're wondering why I didn't go this direction, do I have an angle or a side that's congruent going that way? No, so I'm not going to go that way. Whenever you're tracing it around for these shortcuts, you need an angle or a side from one to the next to the next. So let's, as I talk about this, going this way, so I have a side, yes? Well, what comes next? I have N, then A. So it follows. I can't go this way, because even though I don't have an angle here, I also don't have a side. When we're writing these statements, I cannot skip an angle and a side. I can't have a non-congruent side or angle told to me in a row. Does this make sense? Because going this way is fine. I have a side. I don't have an angle, but I do have a side, yes? So I can go this direction. Questions on this here? So when we're having these shortcuts, I need side, angle, side. I need them connected in some way. This is no, because, well, one, the congruencies just don't match up. Those don't match up. They don't line up. Questions on this here? Okay, I'm going to draw a line. Let's look at this one here. So let's see what we have. I have a set of sides, yes? That are told to be congruent. Well, these two angles are congruent, yes? Is there anything else that's congruent? The middle side, because it's shared. Any line that's shared is congruent because it's congruent to its self. This one, yes, I would agree. Is if we start on this line here, I have a side, an angle, and a side. So that's what we have. Now let's follow the other triangle. Let's follow the same path. So this is the side I started with, yes? On the other one? Side, angle, side. Do they follow the same path? Are the same things congruent in the same order? Yes? So they are congruent by? Yes. Yes. Side, angle, side. Questions on this here? Any questions on any of this here so far? Hey, we have a side angle side and a side angle side. So are these congruent? Why not? So this one here is side angle side. This one here is angle side side, or side side angle. They don't match up. They're not the same. So these would not work. These do not work. Questions on this here? Any questions on anything we've done so far? Do we need to see another example of one of these here? No, we feel comfortable with these here? Yes? Well, this one here would be yes by side angle side. This one would be yes. Okay, what additional information do I need to be able to say that these two triangles are congruent by side angle side? So if it's kind of hard to see what they're talking about, well, let's look at the figure. These sets of sides are congruent, yes? Is there anything else that's told to me that's congruent? So they do connect here, yes? These angles are going to be congruent. Why? Yes. These are vertical angles. And again, as I said, when these first came up, they're going to come up again and again and again. Yeah, they're going to keep coming back up. These here are vertical angles. So I have a side and angle. What am I missing? A side. So I need a set of sides that are congruent. Does it matter which ones I choose? Could I use EG or HJ? I need to know that JI is congruent to IE. Because if these two are congruent, then I have side angle side and side angle side. So to finish this off, I need that these two sides are congruent. Well, vertical angles does help, but it's not a guarantee that those two lines are congruent, because, I mean, I'm showing you two rulers here. Is it guaranteed that these two lines, that this one's cutting in this other ruler in half, are they congruent? No. So just because they're vertical angles doesn't mean that they're going to be congruent, but it's not asking us to say that they are congruent. We're not actually proving they're congruent. What are we doing? What additional information is required in order to say that they are congruent by side angle side? So if I wanted to be able to use side angle side to say that they're congruent, I need what? That JI and IE to be congruent, yes? So we're not actually proving that the triangles are congruent. It's pretty much, if we wanted to be able to say this is true, what would we need to know? We would need to know this. Does that make sense? It's kind of, what additional information do we need? Okay, try this again. Okay, so what additional information do we need for these two triangles to be congruent? Let's see here. I have, these sides are congruent, yes? I have, these sides are congruent. So what would I need? Yes, I would need an angle. Specifically, angle H is congruent to angle L. Because by side angle side, we have two sets of congruent sides in one triangle, matching two sets of sides in another triangle, and the angle in the middle, the included angles, are also congruent. Because we need side angle side. We need a little bit of sass for this. Any questions on this here? How about this one here? Is congruent to WU. Yes. Because we have a set of sides, we have a set of angles. We just need another set of sides. And our set of sides would be XZ or ZX is congruent to WU or UW. However we want to set the two letters. Any questions on this here? Huh? Last two, okay. So looking at this one here, I have a set of sides that are congruent, yes? Do I have anything else that's congruent? The middle line, because it's congruent to itself. So I'm missing what? Angles. So we need three letters because there's two angles there, isn't there? So we can't use one letter. We have to use more than one. Which again, this might seem silly for that there, but really the reason we do a lot of this notation is pretty much to be able to say EF is congruent to FQ. Angle EFG is congruent to angle GFQ. and GF is congruent to GF. Therefore, triangle EFG is congruent to triangle G. Nope, gotta make sure I do this right. QFG. Because we can agree this is pretty much what it's saying, yes? Because I have side angle side, the two triangles are congruent, yes? Now, a lot of this stuff, especially with this angles, seems a little bit tedious, yes? Why do we have to use 3 letters? Why can't we just use 1? Well, some of that, but what this really is, the reason that we do this, because there is a rule set up for it. There's a reason for the rule. That if, let's say none of this was here. Let me get a marker. Let's say none of this was here. None of the information of this, or this. We just had this picture and this here. Or not even this picture. If I just had this here, talking about this here, and Miss Kendall comes walking in and looks at this, she would know that, 1, these triangle markers, these symbols here, we're talking about a triangle. We're talking about 2 triangles and congruent. And the reason we know are these pieces of information here. And really, just from that information, she could be able to recreate this picture, knowing what we're talking about. Not to exact detail, but we know what we're talking about. Even without a picture, because of our notation and how we write, especially the angles, we know what we're talking about. Does that make sense? It gives us more information. It's telling us what we're looking at without actually having to look at the picture. Does that make sense? These would be congruent because of vertical angles. And ST would be congruent too. ST or DS. And that's it. Questions on this here? Any questions on any of this here so far? Okay, before we put everything away, I want to look at 2 more triangles. This one and this one. Are these 2 triangles congruent? Because we have what? So it's not by SAS, I have SSA, yes? Does that one work?
Yes.
Have we shown that it works?
No.
No, because again, when I wrote all of them out, erase all this here, because our different ones that we have side, 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 angle, side, let's see here, angle, angle, side, or side, angle, 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 side, angle, and angle, angle, angle. And so far out of all of these, we've really just shown or seen that side, angle, side works, yes? Now at the beginning of this lesson, I said these are all the possible ones that we can have. Possible. Not all of these will work. Not all of these will work. Questions on this here?